All right, our next section is scatterplots and lines of best fit. So up to now, all of our relationships have been linear and they have been perfect. So all of our dots are always in a line, nice and clean. So now we're going to look at some data and things that aren't clean. So you can see right here on this graph, you've got dots all over. You can see this black line on here. This is what we call a line of best fit. And it doesn't necessarily touch all the dots. It might touch a couple, but there's a location where we want to figure out where to put it as best we can. And it's going to talk about the trend in the data. Okay, so as you can see, these purple dots, they're kind of going up. And so that black line, that's what we call line of best fit, represents that. Okay, so there are different types of graphs. So we have bar charts, we have histograms, pie charts, a whole bunch of different things. This is a scatter plot down here, and you can see it's got a lot more data points than that first graph, and you can start to see a clear trend. Okay, I better just slide that up a little bit so you can see a bit more. There we are. So when we look at this, oops, come on graph, there we go. So this one just happens to be the relationships for people, so partner 1 and partner 2. You don't have to be involved with someone the exact same age as you. There's some variety or some ranges on that, and what you can see is there's sort of a boundary, an acceptable boundary. There's a couple outliers. Outliers is just a term that's talks about a data point that's a little farther from the rest of them. Okay, but there's a general trend that normally people are married or engaged or involved with someone close to their age. If we go up here, there's two other terms we want to just have a quick look at, and that is continuous data. So that's data that can have partial amounts, so dollars, time, those types of things that can have partial amounts. Discrete data, though, is something that's whole numbers, so you could have 2 pigs or 6 people. You wouldn't have 6.2 people. Okay, so that's just another term we want to look at. You do not have to read this or write all this down. I will be supplying this as a PDF. This is just a guide, so if you're doing this by hand, there are a couple of suggestions that can make your work look significantly better and makes it easier for you to set it up. So the key pieces here are the independent variable needs to go along the bottom axis or the x-axis, and that's the exact same thing we did in the previous chapters. The dependent variable goes along the vertical axis. When you set up your graph, and this is just common sense in a lot of ways, count the number of squares on your graph paper. It'll make a big difference in terms of how you lay out your graph. You don't want to make a tiny little graph in one corner and waste all the graph paper. Okay, so it's always valuable to look at your data and see sort of what's your smallest value, what's your biggest value. That gives you something called the range. Okay, and then you have to figure out how you're going to fit that range into the most space you have on your graph paper. So one of those things we do is we normally just count the number of squares, take the range, divide it by those number of squares, and that gives you an approximate scale. Okay, and I'll go through one of those in a second. Double data points, you sometimes give an extra circle around it just to show that there's 2 points there. It has a little bit more weight. Lines of best fit. See if I can get this to go up here. Come on, lines of best fit. There we are. The line of best fit should have an equal number of data points above and below it. That's just, again, just a guide. You're just trying to keep it somewhat in the middle and balanced. This is a big one, though, right here. The line of best fit does not have to go through the origin. It's not a must. It's not, all lines of best fit go through the origin. Some will, some won't. Okay, that's what makes this section a little different. The equation of the line of best fit is found using the points on the line. Okay, and we're going to do this with 2 graphs today. So the equation of the line of best fit is found using points on the line. They do not necessarily have to be data points. Okay, and then lastly, 2 more words. Interpolate means investigate in between data points, and extrapolate, the extra, you can think of it as extra, you are outside of the data range. And then lastly, the edge of your graph is not necessarily where the y-axis and y-intercept are located. Okay, I'm going to do one today with that to try and show that. So let's jump right in. Now, I've already done the setup here. I've counted my squares. Let's get on here. I counted my squares. I know I have 20 by 20 graph paper here. I've looked at my range. Okay, so if I look at these numbers here, my smallest value, let's get some color going here. My smallest value is a 2. My biggest value is a 14. So on my x-axis, I wanted to be able to go from 0 to 20 because I like to build in a little bit of extra space. So I have some room around my data. Okay, so that's my sort of critical information I have to include. For dollars earned, my lowest value is 30, my highest value is 170. So I need to include that information for sure. So I just, again, I tack on a little extra space. Usually it helps me set up my scale to be a little easier. And then that, if you notice here for my scales, on the bottom, each one of these squares along the bottom is worth 1 hour. Now once you set that scale, you can't change it, but there's nothing that says the vertical scale and the X or the horizontal scale have to be the same. So the vertical scale here, every block is worth 10. Okay, so horizontal, every block was worth 1, vertical, every block was worth 10. Okay, so I followed the instructions on the previous page. I've set up my graph. I've plotted my information here. I'm going to do a line of best fit in a second here. But if we had to describe this information, describe the relationship, we would say, well, as the number of hours worked increase, the amount of dollars earned increases. So that's very similar to what we've done in the past linear sections. So now we have to do this line of best fit thing. So let's see if we can get this page to extend so I can kind of fit all of this in here. Okay, so I have to draw my line of best fit. So I'm going to use this tool. You would obviously use a ruler. You can move it around. You can try a bunch of different things. So I'm going to try a line that looks like that. And I'm going to look at, well, something like that is where I would start. And then I would grab one end here and just try and find something I'm really happy with. Okay, and this is what makes this tricky, is that everybody can see a line of best fit slightly differently. So I'm going to do something I think about there is pretty good. So I want to look for the number of data points. I'm close to some of them. I'm going through some of them. I have one that's a little bit far away, but these other guys are so close. I'm going to go with that as my line of best fit. Okay, so now to just read and use the line of best fit, all you have to do, okay, so let's go down here, use the line of best fit to determine the amount earned when working 5.5 hours. So if I grab my pen and I go to 5.5 hours, so I'm working with this axis right here, if I draw a line up until I hit that line of best fit, then I go across, and whatever value would be there, in this case it looks like it's about 70, so I would make about $70. Okay, and this red line that I've drawn in here, on your task, I'm expecting you to draw that. That's how you communicate how you found the number that's attached to the 5.5 hours. So on 13 hours, we would go over to 13, and if you again, using a ruler would be good here. I don't have one handy for the computer, something like that. Okay, so I'm looking at about $160. Okay, and then lastly, 18 hours, we would go out here to 18, go up and go over. If we switch axes, okay, let's see if I can get that to slide down. Okay, use the line of best fit to determine the amount of time spent working when you earn $100. Now this is a little different. We're starting on this side. So now we go over, starting at 100, and then we drop a line down, and it looks like it's about 8 hours. Okay, so I'm not going to do all of those. I think that's fairly straightforward on how you use that. What I do want you to know, though, is you need to show these lines on your graph on how you come up with those numbers. Okay, now the last part. Determine the equation of the line of best fit. So if we remember from chapter 5, things we need: slope and a point. So if I go back to my graph for a second here, I'm going to ignore my data lines. Okay, I'm just going to get rid of some of these guys so I can see a little clearer. Or sorry, my data points. I'm not going to worry about my data points. I'm only going to try and find really easy spots to read off the line of best fit I've chosen. So let's go in here and try and find something that's super easy to read, where the line crosses. That one's pretty good right there. Boy, I'm lucky. I kind of have two data points that actually work. So in this case, I've got one here, and it's a shared data point, so I'm going to go with that one. And then this one up here, see, now let's go with this guy. I'm going to say this one just for it to be a little different. Okay, I don't have to use the data points. I have to use lines on the line of best fit. Okay, or points on the line of best fit. So I would do something like that. My run would be 1, 2, 3, 4, 5, 6, 7, 8, 9 squares, but each square is worth 1 hour, so that's 9 hours. My rise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares, but each one is worth $10, so that would be a rise of $110. So my slope would be 110 over 9. Okay, in this case I might be able to read my y-intercept. It looks like it's about 10. So I could even just grab that right here and say that is 10. And my equation would be something like this. Okay, so 110 over 9 times the time value plus 10. And of course, we also have other strategies we could use. We could use all of our finding equation strategies that we did in our last chapter. And you can just use the information from these two data points, or these 2 points on your line of best fit, to do that. So you could use the algebraic approach, you could use this approach where I just use the graph, a bunch of different ways. Okay, so now the Rock Climbing Club tracked its membership for the last few years. Create a scatter plot, apply a line of best fit. Alright, so there's the data. Here is my scatter plot, and it's not quite as clear. This one's a little rougher. It's a little harder to work with, and this happens sometimes. Depending how you set up your picture, your data can be spread out quite a bit, and you just do the best you can. Quite literally, that's all you can do. So I'm going to choose blue. I'm going to choose some line, I don't know, something like that. See if I can grab that. Yeah, I'll go with that. That's okay. So now, again, I've got about the same number of points above and below. A couple points or data points actually are on the line. That's a good line of best fit. Okay. A couple things to point out though. 2000. This is not x equals 0. So this is not a y-intercept right here. This is really, really important. Even though we've drawn a graph with a scale and some axes, that value right there, if we find the equation of this line, you won't get 2000, you won't get 10 as the line as your y-intercept. You'll get a value that's much, much smaller, probably negative for this graph. This is not, because this isn't an x equals 0, so just be very careful. Okay, there's other ways to set that up, but we'll talk about that another day. Okay, so now if we wanted to say a quick sentence about this, is there a relationship between the year and the number of members? Well, it certainly looks like as the years increase, the membership increases. Okay, it's not super tight, but it's not bad. So we would say there's an increase in membership as the years are going by. How many members might there have been in 2007? Okay, so now if we go to 2007, I'm just going to grab a pen. Maybe I'll try a different tool here. Let's try the line tool. Okay, let's see if I can do it relatively quickly. Choose something smaller. So in 2007, so I go to 2007, I draw a line up, and then I draw a line across, and it looks like there's about, now here's where I have to be careful, make sure I have my scale correctly. So each one of these blocks is worth 2, so that looks like about 26. So I would say there's about 26 members in 2007. How many members might there be in 2010? Okay, so I'm just going to use this orange marker again. Oops, I'm going to go up until I hit that line, and then I'm going to go across. I was a little bit low on drawing my line, so maybe 32 or 33. Okay, somewhere around there. Now when I go to find the equation, and I'm going to try and do this one relatively quickly, I want to find 2 points that are on that blue line that are easy to read. Okay, so I want to skip these half one markers. I don't like that one because it's on a half. I'm going to try and avoid stuff like that. So let's take a look. Let's just say this one's not bad. And that one's close. Oh, it's a half, darn it. Oh well, let's try this one right here, just for argument's sake. And of course that's a half too. Let's say this one here. We'll cheat a little bit. Okay, so now if I draw this, I can get my slope, but this value here, this is 2009 and 30. This value here is 2004 and 20. Okay, so now I'm just going to take those two pieces of information. Just going to jot them down a little bit lower here. You can't see where I'm writing, but I'll show that in a minute. Alright, so now let's drag that down so you can see where we're working here. If we went and did this question like we would from last chapter, y equals mx plus b. Step 2, sub in the slope. We don't have the slope. So if I take these two values and I find my slope, okay, I can say 30 minus 20, 2009 minus 2004, and I get a slope of, that's a 20, my bad. I have 10 over 5, which equals 2. 2 over 1. So I have my slope. Okay, if I substitute in my point, pick either one of these, it doesn't matter which one, but you do have to put the information in the right spots. And here's where things will start to fall apart. Okay, so now you have 30 equals now 2 times 2009. So right away you could see this is going to be something silly. 4018 plus b, if you subtract that, so if you go 30 minus 4018, you get negative 3988 equals your b term. So your final equation here would be y equals 2x minus 3988. Okay, and that's supposed to be your y-intercept. And again, the only reason I'm doing this, I'm not trying to find ridiculous answers, but you can't fall in love that that's the y-intercept. This is not an x equals 0, so this value here is not a y-intercept. Okay, so when you do this with computers and technology shortly, you need to be able to understand what that is saying, and if you get a weird y-intercept value, that's why it's doing it. Okay, that was a little long. I apologize for that. I'll try and keep the next ones quicker. Here's a couple of tiny little questions to try. Thanks for tuning in.